Hello, this is Eunyoung Kim, and I'd like to present my research, DeSIDE-DDI, Interpretable Prediction of Drug-Drug Interactions using Drug-Induced Gene Expressions. This is a table of contents. Because of the limited time, I will not go into the details, so please find the detailed information in the poster. Let me start with the introduction. Drug-drug interactions, also called as DDIs, mean a change in a drug's effect when the drug is taken together with another drug. It is important because these days it is common to take multiple drugs at once to reduce toxic effects but increase the efficacy. But these polypharmacy strategies do not always result in good effects. They can also induce harmful outcomes known as side effects. For example, NSAIDs are not encouraged to take with warfarin because of the higher chance of gastrointestinal bleeding. So, in this research, I wanted to predict polypharmacy side effects using deep learning methods and drug-induced gene expression data for interpretability. This is the research overview. The model consists of two parts: feature generation model and DDI prediction model. Different datasets are pre-processed for each model. Given drug pair and side effect data, each drug feature is obtained using the feature generation model, and then drugs pass through neural networks with gated linear units to consider the co-administration effects. Finally, using latent representations of drugs and the side effect score is calculated. The model is evaluated considering 3 DDI cases, and the model was validated with an independent dataset of DrugBank. To train the feature generation model, I use Link's L1000 data, which provides differential gene expression signatures when a certain compound is treated. After the following pre-processing step, I've got signatures of 19,156 compounds. For the DDI prediction model, I used biosnap data processed to filter rare side effects. And I downloaded 2 versions of DrugBank database for external validation. You can find the numbers in the following tables. Let's move on to the model architecture. The feature model is a simple neural net. It takes 2 inputs, molecular fingerprints, and properties. Then it outputs predicted drug-induced gene expression. With this additional model, we could utilize all drugs in DDI datasets. The DDI prediction model is more complicated, consisting of 2 key modules. The first is co-administer module consisting of GLUs to control the information flow with the consideration of drug combination. In the score calculation model, I applied translational embedding method to make 2 related drugs to be close in side effect spaces. The score was defined as the distance between drugs, and then the margin-based loss made scores of positive and negatives to be distinguished. In this study, I reported model performance under 3 DDI cases. Here, unseen means that it is not used in training. Also, since DrugBank describes DDIs at molecular level unlike 2 sides, I considered a pair is positive if it shows more number of side effects than true positives. As a result, the consortium model showed higher performance compared to 2 related studies. Also, it has the advantage of predicting interactions with unseen drugs. Through external validation with DrugBank, it showed that the model could capture possible DDIs, even harder cases. And the Ablation study showed that both The co-administration module and the embedding contributed to the model performance. The last is feature analysis. I brought an example of cyclophosphamide. The heat map shows the changed features of it affected by each paired drug. Hierarchical clustering was done considering the correlation of features, and different drug categories and side effects were examined for each cluster. In more details, I searched on PharmGKB database for any known compound pathways. Then I found that weighted genes are found in each pathway of the drug pair. In summary, I constructed deep learning-based prediction model for drug-drug interactions using drug-targeted gene expression data to consider indirect interactions at transcriptome level. You can find references here, and thank you for listening. Please contact me if you have any questions.